Hey guys, these are notes for geometry section or unit 1, section 2. We're going to be talking about measuring line segments or just kind of really analyzing a line segment and some of its measurements. But before we do that, here's your mad gap for the day. If you can figure out ape, hack, awful, eyes, and if you put that together fast, you could see maybe what statement that says. And you can write it on a piece of paper, put your name on it, and give it to me tomorrow. Or there's a number stumper right here, 8S on ASS. So you don't have to write those down, but you can try those. And your little comic for the day says, I forgot to make a backup copy of my brain, so everything I learned last semester was lost, which a lot of us might be able to relate to, that sometimes we come back from summer and our brains aren't quite there yet. But hopefully we can start remembering stuff quickly. All right, measuring line segments. The measure of a line segment is the distance between the two endpoints. So if you look at point A and point B, and if you counted 1, 2, 3, 4, 5, 6, 7, that would be a measure of 9. That has a length of 9. So you could say it in 3 ways. You could say MAB, which means the measure of AB would be 9 centimeters or 90 millimeters if you do it by each little teeny line. Or just AB equals 9 centimeters or 90 millimeters. You could use that, or you could do line segment AB equals 9 centimeters or 90 millimeters. All of those mean the same thing, just letting you know. To find the distance between 2 points, we could use absolute value, because distance must be positive. That's why absolute value can be used, because that's what absolute value does. It makes everything positive. It finds out how far something is away from 0 and makes it all positive. So we use the absolute value of the difference of the 2 points. So we find the difference between them, and then we take the absolute value. So like if I was using these, I could do 16 minus 25, which would be a negative 9, but since distance is positive, we put the absolute value there and we get positive 9. Or I could have done 25 minus 16, had a positive 9, and that would come out as a positive 9. So that's how you find the distance between 2 points, find the absolute value of their difference. Again, pause the video if you need to stop and catch up. Example of finding distance. Find the distance between point Q and point R. So let's see, here's Q, here's R, so it's got a distance of 1, 2, because you could do 3 minus 1 or 1 minus 3. That has a distance of 2. Find the distance between R and S. So we have a distance that would be 1, 2, 3, 4, or 7 minus 3 is 4. So that's going to be a 4. Find the distance between Q and S. Now you could do 7 minus 1 and get 6, or 1 minus 7, get negative 6 and take the absolute value and get 6. Or you could look at the 2 previous answers. A 2 and a 4 together, guess what 2 and 4 makes? It makes a 6, because you just put a segment of 2 together with a segment of 4. You put those two things together, you got a segment of 6. So that what we call that is called the segment addition postulate. When you add the two segments together, you get the entire segment. So adding the two smaller ones together, putting it in one bigger segment, you just add them together. So this is called segment addition. It's also referred to as the segment addition postulate. Segment addition. If A, B, and C are collinear. Now from last section, you should remember what collinear means. Co means together, and line means on the same line. So they're together on the same line. So they're collinear. And B is between A and C. So let's draw that. Let's just get a little visual in our head of what we're looking at here. So let me draw a line here. And let me make 3 points on that line. So I don't have to put them at the end if I don't want to. I could put them in the middle somewhere. There's 2. There's 3. So this is what we're talking about. Here's A. Now I did say B is between A and C, so B has to be the middle one. And it says, if that's the case, if B is between A and C, then you could actually say that AB, this piece, plus BC, this piece, putting them together would give you AC, the entire thing. That's segment addition. So here's a little real-life example. A plumber's apprentice needs to cut 54 inches length of pipe so that one piece is twice the length of the other. So we know the whole thing's 54. One of them needs to be twice as long as the other one. How far from the endpoint X should the apprentice cut the pipe? So let's see. So if we use a segment addition postulate right here, substitution would mean that xy plus yz equals xz. Well, what we know right now is that xz is 54. That's what we know right now, that xz is 54. We don't know what the other ones are, but if we want to try to figure them out, we need to set them equal to x, and then plus, and we know the other one is twice as long, so x plus 2x. So I'll put that here. So if I solve this, I'm going to get 3x equals 54. And if I divide by 3, I'm going to get x equals 18. So what that tells me is that the smaller piece is 18. The smaller piece is going to be 18, so I could put an 18 right in here. And if I do 18 minus 54, I'm going to get 36 for the bigger piece. And what's cool about that is now the bigger piece is twice as much as the smaller piece, which is exactly what they needed. They needed one length to be twice as long as the other. So we knew that if one was x, the other one was twice as much as x. And then we added it to 54 and then solved it. Here, you try one. Point A, B, and C are collinear, just like we have up here. Oh, I lost C somehow. How did I lose C? My bad. Here's C right there. Yeah, sorry. Okay, so there's C. They're collinear. They're on the same point. B. This time, actually, C is between A and B. Alright, so let's put C in the middle of A and B for this example. So now we're talking about this example right now. If AC is 3/4 CB and AB is 14, then find AC. So you're looking at that. Now pause the video, see if you can figure out how to do that, and then when you turn it back on, we'll solve it. Alright, let's see how you did. We should have A or CB equaling our X. Let's put that here. This is going to be 3/4 times X, because it says that AC is 3/4 of CB, and then we know the whole thing is 14. So basically we've got 3/4 X plus X equals 14. Now 3/4 X plus X is really going to be 7/4 X, which is 1 3/4. 7/4 X equals 14. And then you could multiply both sides by 4 and then divide both sides by 7, or you could just multiply the reciprocal by 4/7 on both sides. So you could do 4/7, which would cancel out both fractions, or both of these fractions would cancel if you multiplied by 4/7 on both sides. So you would get the 7 and the 14 to cancel out to a 2 and a 1. 2 times 4, your x is going to equal 8. So down here we could put x equals 8. So that means that this piece is 8. And we know the whole thing has to add up to 14, so this piece has to be 6. 8 and 6 equals 14. And it does make sense because AC is 3/4 of CB, so 3/4 of the way to 8 would be a 6. So that is true. Now the picture doesn't quite make sense. Oh wait, CB. Yeah, AC is a little smaller, so yeah, it makes sense. Good. All right, moving on. Midpoint of a segment. So now we've measured segments. We're going to also talk about midpoints. Now the midpoint, one plumber need to cut it into 2 equal lengths, 54 inches. The point where we would cut the pipe is called the midpoint. The midpoint divides a segment into 2 equal pieces. So if we had the 54-inch pipe, the midpoint would be where they're both 27. If x, y, and z are collinear, okay, so x, y, and z are all on the same pipe, they're all on the same line, and x, y equals y, z, then y is the midpoint of the segment. This point has to be the midpoint if the two sides are equal. That means you found the exact middle point if the two sides equal to each other. You can see the diagram from mathisfun.com here. The midpoint breaks it into 2 equal pieces. So the middle of, or the point halfway along, try moving points A and B. So check it out on Math is Fun. Go to your other website here and just check it out. If you move A, there's the midpoint. It's going to stay in the middle. It's going to move with it. I can get really close. This is still going to be the middle point. I can move B, and that'll still be the midpoint because it breaks it into 2 equal pieces. So midpoints always break into 2 equal pieces. So that's midpoints. Now example of finding or using a midpoint. It says NASA contracted for the development of the space shuttle in 1972. After 4.5 years, right here, the project was halfway done. When the Enterprise began first flight tests, use the segment below to determine the year it was launched. So if we went 4.5 years, from 1972, 4.5 years would be 1976.5. If you went 4.5 more years, that would be a total of 9 years. So from 1972, this would have to be 9 years later to 1981. And then you could always count it and make sure you got it right, because 73, 74, 75, 76, 77, 78, 79, 80, 81. 9 years, because they both had to be 4.5 years. Now if you look at what I put here, I put that DC, this whole thing, equals 2 times DE. 2 of these DEs makes the whole DC. So if DE is 4.5, then DC has to be 9, because 2 times 4.5 would be 9. So 9 full years. So midpoint of a line segment. The midpoint is halfway between the 2 points. So all we have to do is calculate the average of x and the average of y between 2 points. Now, we're using the Cartesian points here, so I want to show you how to find the midpoint when it's on a graph. So when it's on a graph, you're going to take the 2 y values. So this point you went up here, and this point you went up here. The 2 y values together and divide it by 2. That's going to give you how far to go up. Down here, you take the 2x values. We went over to get to B, we went over here to get to A, so we add those two together, divide by 2. That's going to be your midpoint of how far you went over. And so that'll be the midpoint. You average the x's and you average the y's. So add both x's and divide by 2, add both y's and divide by 2. This is what you'll end up with. A midpoint formula is x of your A point plus the x of your B point added together and divided by 2. The y of your A point plus the y of your B point and then divided by 2. Again, always pause the video if you need more time to catch up. Just pause it and then move on. The midpoint has a formula. You add them, divide by 2. You add the y's, divide by 2. Study this chart right here. See how it works, and you can always see how to find the midpoint. You know it has to be in the middle. You know it has to be exactly halfway. So that's going to be the average of the 2 points. Here's an example. You got negative 3, 5 is like your point A, and 8, negative 1 is like point B. The midpoint formula says to add the x's. So my x is being negative 3, and my x down here is an 8, and it says divided by 2. It also says to add the two y's and divide by 2. So I took the negative 3 plus the 8, those are my two x's, divided by 2. I took the 5 and the negative 1, add the two y's, divided by 2. You're going to get a 5 divided by 2. You're going to get a 4 divided by 2. So you're going to get a 2.5 and a 2. So you go over 2.5, you go up 2, that's your midpoint. This point breaks this line into two equal pieces. That's what a midpoint does. All right, thanks guys. Cut them out and paste them into your notebook.